What do they say? Are they talking about like your course extended warranty?
No, they put weird links
that they want me to click.
like oh. Okay, so last time we had a term on this side and we decomposed into 3 parts. If I multiply by the denominator from this side, that's what we would get. Our objective is to find C1, C2, and C3, just like we found C1 and C2 for the second order difference equation. Sorry, I made a major mistake. All of these should be products, not, quotients. So I'll just erase this and put it as to make that change. Or else it's going to go nowhere. How did we solve for C1 and C2 when we had a second order difference equation?
Did the cross multiply?
We already did the cross multiplication, right? That's how we got these terms. If you look at notes from last time, we had this. Good. But if they multiply these, and that's what you would get. But at this step, we use something to find the values of C1, C2, and C3. So we try to make C2, or we try to make these 2 terms go away, and found an expression for C1. Then we try to make those 2 terms go away, found an expression for C2. Then we made these 2 go away, found an expression for C3. You can look in the notes. I plugged in different values of Z to get rid of each term.
So if you want to get rid of C2 and C3, you would like 1 over C1. Or 1 over whatever the one.
Good. So let's do let Z is equal to 1 over lambda 1. If I did that, I'll get 1 equal to C1. 1 minus lambda 2 times 1 over lambda 1 is lambda 2 over lambda 1 minus lambda 3, 1 over lambda 1, I'll get lambda 1 plus C2, 1 minus, okay, that one will go away. The reason being lambda 1 times 1 over lambda 1 is 1. 1 minus 1, 0, gone. Same over there, that is going to be gone. So that's all we have left. So C1, lambda 1 minus lambda 2 over lambda 1, common denominator to combine those 2. Same here, lambda 1 minus lambda 3 divided by lambda 1. Yes? Which is going to give us C1 lambda 1 minus lambda 2, lambda 1 minus lambda 3, divided by lambda 1 squared. Yes. So we can solve for C1 easily. this would mean C1 is equal, multiply by lambda 1 squared on both sides and divide by that term. So lambda 1 squared would be equal to C1 lambda 1 minus lambda 2 times lambda 1 minus lambda 3. Let me so far. Now I'm going to divide by that term on both sides. Have lambda 1 squared divided by lambda 1 minus lambda 2, lambda 1 minus lambda 3. Good. Now we want to find C2 and C3 using a similar process. So to find C2, what would you use Z?
1 over lambda 2.
To find C3, what would you use? 1 over lambda 3. Let's give it a try and see what we get for C2 and C3. Very similar process. So if we set 1 over lambda 2, that would get rid of the first two terms, the first and the last term. We plug in 1 over lambda 2 second term and solve for C2. C2 happens to be related in this manner. If you cross multiply by this and divide by the numerator, we will have C2 is equal to lambda 2 squared divided by lambda 2 minus lambda 1, lambda 2 minus lambda 3. Good. Now, I'm not even going to bother plugging in, z equals 1 over lambda 3 and trying to find the value of C3. Instead, I want you to look at that expression. I want you to look at this expression and tell me what C3 is going to be. There is a pattern.
Lambda 3 squared over lambda 3 minus lambda 1 times lambda 3 minus lambda 2.
Very good. So we directly can see that there is an underlying pattern in the C2s. So, in the C's. So C3 would simply be equal to lambda 3 squared divided by start at lambda 3 minus lambda 1, lambda 3 minus lambda 2. Good. So we've got C1, we've got C2, we've got C3. Last time we came up with that final expression for the size, right? What was our expression for size?
If 1 over that.
The big side of Z, right? And we had that big side of Z and we expressed it in terms of C1 and C2. Remember, last time, once we found C1 and C2, I took this denominator, or took that term, 1 over 1 minus lambda 1 Z, expressed it as a geometric series. Did the same with the second term, expressed it as a geometric series. Combined the C values and then got an answer. So if you look at our expression, we ended up getting C1 lambda 1 raised j, yes, plus C2 lambda 2 raised j. Correct. That's for a second order difference more. And that's how we found the sideways. Now I want you to take a guess. Well, if I want to extend this to a third order difference model, what would psi j be?
Would it still be the, would you just add on a plus C3 lambda 3j?
Do we agree with Alex? Yeah. So psi j would simply be C1 lambda 1 raised j, C2 lambda 2 raised j, C3 lambda 3 raised j. Good.
And so on and so forth. But if we end up like the fourth order or fifth order, just keep adding C's, J's.
Yes. So give me a second so I can simply write C1. We have C2 over there. I guess. C1 would be lambda 1 squared divided by lambda 1 minus lambda 2, lambda 1 minus lambda 3. Yes. And C3 would be lambda 3 squared divided by lambda 3 minus lambda 1, lambda 3 minus lambda 2. Good.
Yes.
So there is a nice pattern that is evolving. You may say, well, when we did the second order difference equation, there was a negative in it. But you don't see that negative here. But if you go back and look at the way we did that, we pulled out a common term, and that was lambda 1 divided by lambda 1 minus lambda 2. So if you look at these two terms, I have lambda 1 minus lambda 2, I have lambda 2 minus lambda 1. So if I pull the negative out, I'll get lambda 1 minus lambda 2, right? So C1 and C2 would be related in that manner. C2 and C3 would have a similar relationship because that and that are in reverse. So you'd have plus, minus, and so forth. Eventually, terms would get cancelled. So I can easily generalize this for a nth order difference equation. Any thoughts?
Would it just be that you feel like I
Good. Which I can write it as
Just because of the mutation.
Oh, what do you mean?
Why is it not CP rather than why are you using K?
Because I'm just simplifying this notation. So what I'm saying is the sum of all those terms, I could simplify and write it this way. So when K is 1, it's that term, K is 2, that term, and then summing all two.
So like K is approaching.
Yeah, it's 1, 2, 3, 4, all the
Yeah,
way.
that makes sense. I was just in the mindset that P was denoting the general.
But do you follow it?
Yeah.
No,
Some notation.
now that we've addressed this, for any P, since it's a P order difference equation, let's just take C sub P. Of course, I need to change the value of P, 1, 2, 3, and so forth. How would I write at C sub P?
Or would it be like when the P squared?
Would it be squared then?
I think that one would be squared, wouldn't it? Like, it seems like,
I'll call it J, not P. Oh, I used K, so I'll call it say K. Now, maybe you're not seeing this. So let's write the second order difference equation coefficients also.
would it be, the lambda, P or K or whichever variable we're using, to the K minus 1?
K minus 1, P minus 1.
No.
So the order here is P equals 2. There, P equals 3.
Yeah, P
So it
minus,
can't be K minus 1, right? If it is K minus 1, if this is K, K minus 1 is 0. So it can't be the correct value.
P minus 1
Has to be P minus 1. Why? If P is 3, 3 minus 1 is 2, 3 minus 1 is 2, 3 minus 1 is 2. Works. So I could write it as P minus 1.
But it's always squared already.
Because all P is always 3. That's a third order difference equation. P is 3. So we will have P minus 1, P minus 1, P minus 1. Great. Now let's look at the denominator part. Well, let's start with C1, and you should see a pattern.
So it'd be like, what, lambda K minus lambda K plus 1 times lambda K minus lambda K plus 2.
What? How about this? Can I write it as lambda K, right, minus lambda 2, lambda K minus lambda 3, dot, 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 all the way up to lambda K minus lambda K.
That's what we're true K equals 1.
It'll work for K equals 2 also.
What if it's lambda P minus 1?
I see. Well,
Wouldn't it be K minus 1?
let me write it this way. How about this? use that K notation. So it's lambda K. We start with C1. This would be lambda 1 minus lambda 2, lambda 1 minus lambda 3, all the way up to lambda 1 minus lambda p, except lambda 1 minus lambda 1. Correct, because that will make it 0.
Could you have to define that K as non-moving in order to?
Yeah. So if you look at C2, this would be lambda 2 raised to p minus 1. It will start at lambda 2. You will have lambda 2 minus lambda 1, lambda 2. It can't equal lambda 2, but it'll move on to lambda 3, lambda 2 minus lambda p. Right? So as it pointed out, I could simply write it as ck equals all of that. K just cannot equal p. So C3 would be the same process. Lambda 3 raised to p minus 1 divided by lambda 3 minus lambda 1, lambda 3 minus lambda 2, all the way up to lambda 3 minus lambda p. Good. K just cannot equal the value, 3 in that case. It'll keep on going.
Are you gonna write it in terms of K? Or do you not get there?
So in terms of K, this would be lambda K raised to p minus 1, lambda K minus lambda 1, lambda K minus lambda 2, to lambda K minus lambda p minus 1. K cannot equal p. Does that make sense? So we're just dropping one term at a time. So here we dropped lambda 1 minus lambda 1, then lambda 2 minus lambda 2, and so forth. So in this case, K cannot equal p. Good? So that would be the expression. Nice, right? If I have to write it in a very simple form, this is the same as saying lambda K raised to p minus 1. Instead of sum, we have a product. Just like a summation symbol, this is a product symbol. I can write it as lambda K minus lambda r. And we got the coefficients that we need. Pretty nifty, right?
And it's supposed to be
The three weights are these. P1, P2, P3. So Phi1, Phi2, Phi3 are the phi weights. We are going to find psi 1, psi 2, psi 3, but we can go all the way up to infinity, right? But those are all the psi weights. This is a very standard notation to understand, time series models. Typically, most textbooks would adhere to this. Okay, so let's start. First, we've got to find the characteristic polynomial. Yes. So Give me 1 second. So the first step is to move everything to the left-hand side, which would give us 1t minus 0.8 yt minus 1 minus 0.3 yt minus 2 plus 0.1 yt minus 3 equals wt. Yes? Now, as we have good experience with coming up with the characteristic polynomial, you should be able to come up with phi of z, the characteristic polynomial on the left-hand side, just by looking at it. That's if you can tell me.
So you have 1 minus 0.8 L.
We're going to replace L by Z, right?
Okay.
So 1 minus 0.8 Z
Minus 0.3 Z squared plus 0.1 Z cubed.
So
Yeah.
now that we have good practice, we don't even have to sit and apply the lag and whatnot. We're done. Now, we want to find the roots Z1, Z2, and Z3. Z1 happens to be 1.
Wait, shouldn't they all be minus though? Or is it plus?
This one is negative. It moves to the other side to become positive.
Oh,
So Z2 is minus 2.316. 6. Z3 is 4.3166. Now, one of the roots is exactly 1. So this is called a unit root, and unit roots are quite important in forecasting. So we will talk about it, eventually. So one of the roots is a unit root. How do we find the lambdas? Lambda 1 is simply 1 over Z1, which is 1. Lambda 2 is 1 over negative 2.3166, which is negative 0.444.
Yeah, negative 0.4316.
0.4316. And lambda 3 would be 1 over positive 4.3166. It's negative 0.23. Right?
Wait, how would that become negative?
Oh, it's positive. So 1 over 0.43166 would be that.
By the way, on an exam, are you gonna be giving us the roots or are we gonna have to find it?
You'll have to find the roots for a third degree polynomial. Sometimes I'll give it to you, but there is a way to find it using the calculator, and I will show you how. There is a neat little pattern going on here. Are you able to see it? Is this correct?
Yeah, I made a round error on the first one, it was 4317 and 2317.
Okay, because it's 6667. Okay, it's all right. Okay. could change it to 7. By all means, 6, I could have rounded that to 7 as well. Now look at that, there's a nice little connection.
You're basically just kind of moving the decimal over.
One, we're moving the decimal over and we swapped lambda 2 to lambda 3. So it was lambda 2 became the Z3 decimal over, right? Isn't that interesting? And this pattern would follow for, all lambda 2, excuse me, all lambda k's throughout. So we know the lambdas now, so we can find the c's, right? So C1 is simply lambda 1. Is it raised 2 or raised 3? 2. Divided by lambda 1 minus lambda 2, lambda 1 minus lambda 3. And numerator is 1. So we'd have 1 minus of minus 0.4317 plus 0.4317, 1 minus 0.2317, multiplied by 0.7683. .2 denominator. Then everything, we get 0.99 something. Or 0.9.
How did you get the version? Negative 2.3166.
This,
Yeah.
I used R, but I'll show you how to find this using the calculator.
And then why is that first one plus, like 1 plus 0.4317?
Because there's one.
Negative,
Oh,
negative, negative,
oh,
negative, negative. And what is that first value?
0.909. Or 0.909.
C2 would be lambda 2 squared divided by lambda 2 minus lambda 1, lambda 2 minus lambda 3. Which would simply mean we have negative 0.4317 squared, negative 0.4317 minus 1, negative 0.4317 minus 0.2317. We plug that all in. What 0.61? 0.1966.
0.1966.
Yeah, 0.1962.
Yeah. 2.
Okay, and lastly, we're going to erase this. C3 would be lambda 3 squared divided by lambda 3 minus lambda 1, lambda 3 minus lambda 2, which would give us, what is lambda 3? 0.2317 squared divided by 0.2317 minus lambda 1, which is 1, 0.2317 minus lambda 2, minus of minus would be plus, get 0.4317. And what is that value?
Is negative 0.1053.
0.1053. Good. Since we found C1, C2, and C3, we can write psi for any j, right? So psi j would be C1 multiplied by lambda 1 raised j, which is simply 1. C2 multiplied by lambda 2 raised j, C3 multiplied by lambda 3 raised j. C1 is 0.9091. Lambda 1 raised j, lambda 1 is just 1, so I'm going to leave it as is. Right? 1 raised any power is just 1 plus C2 is 0.1962 multiplied by lambda 2 raised j. Lambda 2 is negative 0.4317 plus C3.
Wait, don't need to read J.
Yes, j, and negative 0.1053 multiplied by 0.2317.
I think you forgot a sign in between 0.1962 and negative 0.4. But there should be a plus there, right?
No, I'm multiplying C2 and lambda 2 raised j.
Oh, because that's,
Yeah, that's multiplication. So this one is just 1.
yeah.
So our final answer for psi j is simply (9091) plus 0.1962 raised negative 0.4317 raised j minus 0.1053 0.2317 raised j. Good. And j can be any value starting at 0. So 0, 1, 2, 3, dot, dot, dot. Keep on going all the way up to infinity. I want you to plug in j equals 0, which would make that 1 and that 1. and plug it in and tell me what size 0 is. A thing that is very unique or interesting is that size 0 last time was 1, second order difference equation. Size 0 this time is 1. So even if it is a peak order difference equation, size 0 must be 1. If you don't get 1, then you made a mistake. Does that make sense? So size 0 has to be 1. It's like we didn't make any mistakes. Now, I want you to look at this picture. So this simply states, now this goes back to something that I ended with last time and Alex asked me this question. Other question. So we did something like this last time, right? Where we simply said what you are today is a combination of random things that happened in the past. So I'm going in steps of 3 because I don't want to crowd the picture. I'm going from 0 today all the way up to 100 in the past, right? All random things that happened in the past 100 days. And I'm putting a linear combination, and this is what happens. Those are the psi values. So there is a huge difference between this graph and the graph that we saw last time. What was it?
Well, he said this person would be a psychopath.
Exactly. Yeah, probably mentally ill or, could be a psychopath because the person's weight today is sort of consistent. They're adding everything from the past all the way up to 100, and this pattern will be consistent all the way up to the day they were born, right? Things do not change at all. But if you looked at the curve last time, it was nice. It started here and it decayed nicely, correct? So that is a stable model. This is not a stable model. Does that make sense? Now, earlier, I mentioned, one of the roots is 1. Unit root. I mentioned unit roots will cause problems in terms of stability. That's exactly what we saw. So we don't want unit roots. And there are ways to handle those, and I believe that comes in chapter 7 in the textbook. But I will try to kind of introduce the concept of unit roots also. Are we clear? That is a third difference equation, or third order difference equation. Now, if we took each of the psi values, psi 0, psi 1, psi 2, psi 3, we can write it the way we wrote last time. But unfortunately, beyond a certain point, it'll just be the same value. Not much will change.